In this video, we're using our next example, which is named Video 14.2 animation. And it's reusing the same ideas that we used previously, but this time we're introducing the concept of a class. I call my class AnimatedBackdrop, and this is the object that we're going to create in order to run the animation on the single line in command window. So if you haven't reviewed already the current chapter of the book regarding classes and the corresponding tutorials, now it's good time to revisit all these topics. But if you're ready, then you should be able to recognize that I have a definition of a class. I would recommend to use multiple files and basically move this class to a separate module, but for the sake of simplicity of our demonstrations, I just keep every example in one Python source file. So the responsibility of this class is to maintain the state of animation, which includes the backdrop, which is a string, frame index, which is an integer, frame per second animation speed, and the maximum, which indicates how many frames we would like to display. Okay, so you should recognize that this is a constructor of a class which is invoked as soon as we create an object. The object is created in our main program, and this is how it looks like. We just simply say that we'd like to have an animation object, and you use the name of the class. It will be recognized by Python interpreter as a request to create an object and invoke its constructor. So constructors in Python look like this. You say define function name in it, and we specify the initial parameters that we'd like to use to populate our object with all of these data attributes we already discussed. Of course, we need to take these constructor parameters and actually assign them to a self, which is a reference to an object itself in memory, and create all these data attributes. Of course, the data types will be assigned dynamically from the types of these objects. You can see that maximum, for instance, is 10, and backdrop is a string, right? So integer, string, another integer, and another integer. So when we create these parameters, these data attributes inside of our objects, they will inherit the data types of these parameters. At the same time, as soon as we use the division operator, it returns a floating data type. So frame interval is going to be a floating data type. Then we normally populate our class definition with member functions of this class. And so far, I have added two of them: print backdrop, right, and next frame. So next frame logic you will instantly recognize as the same, pretty much copy and paste of what we had in our latest version of animation, which was here named animate4 next frame in our first example file. So this time this is called next frame, and it does the same thing, basically disassembles the backdrop into a list of individual characters, then decides what characters to display, and updates the frame with specific digits to display, and then basically just schedules the next frame to run, to be invoked, and it's just simply invoking this very function, self next frame, inside of our object, and uses the time interval to specify how long to wait until the next frame should be displayed. Okay, so what is a huge benefit of adding class in our instance is, of course, that first of all, we no longer have to use global variables. We rely on the data attributes inside of our object, right? So the actual main program, which can reuse this object just the way you like, is creating an object and basically calls the next frame to run the animation. So of course we have a lot of information that we need to observe in the series of lectures about classes, but one specific to Python note is that in Python, all class functions are static, so they require the self designation. So this is the object reference to the object itself, right? And this is why we have to use it even in front of our function. And every argument, whenever we use the arguments and we need to refer to object functions or any member, right? We need to use self in front of it when we need to pass it as a parameter. In this case, we're passing it to a timer, which would like to start at this interval. So frame interval is being created as data attribute inside of our class, inside of our object. And so here we are going to pass it as self, and next frame is the function that we would like to invoke, and also we need to say self. Okay, so that's just because it's a member function of our class. So what else? Again, the first place which benefits tremendously from adding this class is this main program. Basically, create an object and animate. One remaining thing is that we still need to resolve the problem to wait for animation to complete. This is simply a reorganization of the code, but we still have to add the logic to wait for the animation to finish before attempting any further interaction with the user. So right now the main thread after displaying the first frame and scheduling the animation using the timer of the threading module, what it does is simply exits, right? So we don't print anything, we don't interact with the console anymore. Okay, so this is a limitation of the sample, but it captures the technique of restarting this function using the timer. Okay, so let's do a very quick demonstration of this program. We can reuse the same console, and I will just basically drag and drop this video 14.2 animation.py here in my command window, and I run it, and you can see it just animates the counting from 0 to 10 and uses the specific background and just places at specific position these digits, using exactly the same technique that we used over here in our early example with the background display.